This is a recording for Wednesday's lesson 217. We're going to start with this warm-up. This is similar to yesterday's, only we're doing it as a fraction. So instead of writing it, 1/2 as an exponent means the same thing as the square root of x plus 30. So how would I get rid of the square root? I square it, but we raise it to the reciprocal power. Raising both sides to the second power, that's what cancels out the exponent of 1/2. Another way to think of it is when you raise a power to a power, you multiply. Multiplying a number by its reciprocal, 2 times 1/2 is just 1. So I cancel. That would give me x plus 30 equals x squared. This is clearly a quadratic, so I would minus x and minus 30 to get it equal to 0. Factors of 30 are x minus 6 and x plus 5. That would give me -1. So when I set those equal to 0, I would get 6 and -5. And then if we check that, this is one that's probably easy just to check by plugging numbers in. Plug 6 in, and I would get the square root of 36, or 6, and that equals, plug 6 in for x over here, 6 equals 6, checks out. Let's check -5. If I plug -5 in, I would get 25. Square root of 25 is 5. X equals -5. 5 does not equal -5, so this does not work. It's extraneous, and 6 does work. Now, something different from yesterday, taking an equation that has a fraction exponent, but something like 3/4. So, order of operations in reverse, I would start by minusing 2 from both sides, and that would give me this line here where it's equal to 8, when we minus 2 from both sides. And then I need to get rid of the exponent, because 2x is in parentheses, that comes last. So how do I get rid of the exponent? I'm going to write it over here so it's clear. And you can see they're raising it to the reciprocal power on both sides. So to get rid of the 3/4, I'm going to raise both sides to the reciprocal power of 4/3. And 3/4 times 4/3 cancels out. It makes 1. So what I get is 2x equals 8 to the 4/3. Now we know how to do this. We know the denominator is the index. So that means take the cubed root of 8 and raise it to the 4th power. That's what 4/3 means as an exponent. Cubed root of 8 is 2. 2 to the 4th power is 16. And then I get x equals 8 as the final answer. Okay, so again, just like yesterday's, only you're using fraction exponents, and you have to do the reciprocal power. Now we get to the harder ones, and you can see, look at all the work here. This might be easier if we take it and do it from scratch. That note document will be posted, so if you want to take a look at it, you can with all the words written out. But let's just do it from scratch here. I have square roots on both sides. Now, if the x plus 1 wasn't there, I could just square both sides. Both square roots would cancel, and that would be an easy algebra 1 solve. That's not what we have. So what I need to do is, how do I get a radical by itself? Well, I do have a radical by itself. On the right-hand side, this radical is by itself. So I can go ahead and just go on to squaring both sides. But remember, I can't square these terms separately. I am squaring this side as one whole quantity. So I square both sides. On the right side, the square and the square root cancel. On the left side, what I have is the square root of x plus 2 plus 1 squared means times itself. So I have to distribute this out. So let's work on distributing. Square root times the square root, that just makes x plus 2. Okay, like the square root of 7 times square root of 7 is just 7. So the square root of x plus 2 times itself is just x plus 2. And then I have 1 square root of 2, or x plus 2. And then here I have 1 times the square root of x plus 2. There's another one of those. And then 1 times 1 is 1. So what I have is x, let's clean this up. 2 plus 1 makes 3. I have 1 square root of x plus 2 plus another 1, or 2 square roots of x plus 2. Adding, combining like terms. 1 here plus 1 here makes created is another square root. But now, instead of having two square roots like we did at the beginning of the problem, there's only one. So now let's go ahead and solve. So I'm going to start by subtracting x. We're starting back at the beginning, order of operations in reverse. I'm going to minus 3 from both sides. So that cancels these out, and I get 2 square roots of x plus 2 equals, well, 3 minus 3 is 0. That's kind of nice. Negative x minus x is negative 2x. Watch your signs there. Now I'm ready to divide. So let's divide by 2. The square root of x plus 2 equals negative x. The 2's cancel. Now it's getting more simplified. Now we're ready to square both sides. X plus 2 equals negative x squared is a positive x squared. You know, a negative squared is a positive. Now we have a nice easy equation to solve. This one is actually a little bit easier than some. This can get more complicated than this because things canceled out here nice and cleanly. So let's subtract x and 2 to both sides. Now we're ready to factor and solve. X minus 2 and x plus 1. X equals positive 2 and negative 1. And then we need to check those. And I'll just show the check over here. When they check, here's 2 and negative 1. When they check 2, it doesn't work out. So 2 is extraneous. When they check negative 1 does work. So that's the only solution. The other one is extraneous. Alright, you can go to